Today, for my CMPE 255 data mining assignment, I am taking you on a deep dive into a problem that frustrated data scientists and business analysts for decades, and I will show how AI is finally fixing it. The topic is when tables finally started making sense, which is like a deep dive into LLM models and data querying and the shift from SQL to natural languages. Now, before I jump in, let me explain why I choose this specific topic. In our DM courses, we spend a lot of time talking about clustering, classification, and complex algorithm. But practically speaking, the biggest bottleneck is data mining isn't usually the model; it's the access. So, how do we actually get the right data out of massive and complex databases? To even begin mining it, usually you need to know SQL. But what if you could just ask the database a question in English, like what we do in ChatGPT? That's the frontier I want to explore today, bridging the gap between natural language and structured data. So, if we go to our next slide, as we can see, in our left side we have structured Cilio. Companies today are sitting on the gold mines of data. Data like customer transaction logs, inventory, which is stored in SQL database or massive data warehouse like Amazon, Meta. They have the data is rigid. It follows strict rules. To talk to it, you need to speak its language, which is SQL. On the right side, as we can say, we have a human disconnect. Human don't think like in SQL language, like select star from tables or database languages or something. We think in questions like we ask who are our most valuable customers, why did the sales drop last month, what was the sale for this week, or something like that. For years, this disconnect meant that if a business manager wanted an answer, they had to file a ticket with a data analyst. The analyst would write the SQL, run the query, and send back a CSV file. This manual process kills the momentum of data exploration. My goal here is to share you how we are using AI to remove that middleman. So for that, the concept isn't new. We have tried doing this for years with rule-based system. Basically, hard coding keywords. If the user said how many, the computer will look for a count. But those systems were incredibly fragile. If you paraphrase the question slightly differently, the system will broke. So what changed recently in the arrival of LLMs? We moved from like simple keyword matching to genuine reasoning engines. We are now treating the translation of English to SQL not as a coding task but as a language translation task, similar to translating English to French. So as we can see this diagram, and here is the flow. So let's look under the hood. This is the modern architecture of text to SQL system. It's important to understand that we don't just ask ChatGPT a question like and hope for the best. It's a pipeline. Like we give a prompt and then we get an answer, but if, we can redefine the answers also. So the user asks the question. We start with the query and then the context it gives, like this is a crucial. The LLM doesn't inherently know your database structure. We have to feed it the schema, the list of tables and columns. RAG. So this is a key term in AI right now. If I have a like database with 1,000 tables or like 100 tables, I can't send all of them to the AI. It's too much noise or too much data. We use RAG to retrieve only the relevant tables first and then later to on. And for the generation, the finally the model generates the SQL. So you can think LLM as a here as a compiler, which we have in most of the languages like Java or C++. It takes high level human intent and compiles it into low level database execution code. As we move forward, we can see that if this like If it this sounds easy, let me tell you that it's not. The biggest hurdle we face is the field is called schema linking. This is a problem of ambiguity. Look at the example of a slide. A user might ask like, show me the revenue. To a human, that obviously the like that's obvious, but look at the database. There is no column named revenue. So there is a sales amount, there will be a sales amount, there will be a gross income or a total revenue of like, but the like which one is it, we don't know. So the model has to use the reasoning and metadata to figure out that revenue most likely maps to a sales amount, or which will be multiplied by quantity. It also like has to figure out how to join tables. If the user asks for customer revenue, the model needs to know it has to join the customer table with the sales table using a foreign key. This is where most models fail. They hallucinate columns that doesn't exist. Moving forward, like I wanted to dig deeper into what actually makes these models work, so I looked at some ablation studios. For those new to the term, an ablation study in which where you remove parts of a system to see what breaks. Here is what the research tells us matters most: foreign keys. If you don't explicitly tell the LLM which columns link tables, the primary and the foreign keys, the performance drops, but by about like 15 to 20%. The model needs a map of relationship. Schema filtering. Less is more. Like if you give the model too much irrelevant info, it gets confused. Filtering the schema before prompting is critical. Chain of like reasoning steps or chain of thoughts, you can say. This is a prompting technique where we ask the model to explain its logic before writing the code. Surprisingly, just asking the model to think first significantly reduce logical errors. As a result, we can see the reality check, where we can see how good are we at this. uh, Sorry, I went one step ahead. Yeah, so as a result, we can see that how good are we at this. And the industry standard benchmark is called spider. If you look at the blue bar, spider one, we are doing amazing, over 90%, like over the 90% accuracy we have. This represents simple questions like how many users are there. LLMs have basically solved this. But look at the red bar at the bottom, that is spider 2.0, which represents real world enterprises queries. We dropped to 10% accuracy. This is the reality check in an academic settings with clean data. LLMs are geniuses, but it in a messy enterprise environment with thousands of columns and weird naming conventions, they still struggle massively. This is why human analysts are not losing their jobs anytime soon. So the question arises: why is enterprise so hard? So I want to elaborate on why the red bar was so slow. Why is enterprise data mining so hard for AI? First, it's a like a scaling the things. A real company might have a Salesforce database with around 4,000 tables. You literally cannot fit that schema into the context window for a normal LLM. Secondly, ambiguity. In a real company, the definition of metric like churn changes depending on who you ask. Is it a user who cancelled or a user who hasn't logged in for 30 days? The LLM can't guess that business logic. And finally, dialects. Standard SQL is one thing, but complex optimized queries for Snowflake or BigQuery require very specific syntax that generic models often miss. So as we move, we will see the future of this. So what is next? Where is the field going in 2024 and 2025? We are moving away from simple text to SQL and moving towards autonomous data agents. Imagine an agent that doesn't just write the query but also executes it, sees an error, fixes it by like fixes its own error and then use the Python to visualize the results. We are seeing a shift from chatting with a database to agentic analysis, where the AI acts as a full stack and data scientist. This will be a game changer for exploratory data mining. Also, if we go to the summary, uh, to wrap up things, here are the key takeaways from my research. LLMs have fundamentally changed data interactions. They act as universal compiler that translates human thought into machine code. However, the frontier is no longer just about language models. It's about context management. How well we have feed the right metadata to the model to handle messy real world data. For this assignment, I really wanted to highlight that data mining isn't just about the math once you have the data. It's about the architecture of accessing it. Thank you for watching. I have listed the references to the Spider 2.0 benchmark and the survey papers in the slide deck. I hope this gave you a clear picture of where AI meets database systems. Thank you.